Good morning, children. Today we are going to study a new topic. The topic is what? Electric current. Before going to the particular topic, let me recapitulate the concept what we have studied in previous class. In previous class, we have completed activity 1. What is that activity 1 gives information? If there is a relationship between electric charges which are flowing through a conductor, material will play a vital role, source will play a vital role. If these material as well as sources are connected in a closed path, free flow of charges will be taken place. How these particular charges are flowing through the particular connecting wire? When we are connecting a source, that source creating a uniform electric field around the conductor or charge carrier and allows that particular electrons to carry energy from high potential to low potential, which is called as a current. We have seen clearly that if charge material charge carriers are conductors, free flow of charges will be taken place. If charge carriers are insulators, no free flow of charges will be taken place. If we are not connecting a source to a circuit, also no free flow of electric current will be taken place. That particular activity we have completed. Today, a little bit more information regarding electric current we are going to discuss. What does this particular theory explain? What is meant by electric current? Rate of flow of charges is called as electric current. This particular concept was first explained in the year 19th century by two different scientists. Their names are called as Drude as well as Lorentz. They both together proposed that conductors, we have seen clearly that but charge carriers if it is conductors. We have seen clearly in previous classes that electrons will play a major role in carrying energy from one place to another place. Therefore, they said that conductors like metals have large number of electrons. That is how many? 10 to the power of 29 electrons per meter cube. And they also said that these electrons will carry charge. They are nothing but what? Charge carriers. And within that also there are existing positive charges, also positive ions. They said that electrons are charge carriers and positive ions are nothing but what? They are fixed at one region. That region is called as lattice region. We know clearly that. Let me explain a little bit clearly. Let me explain a little bit elaborately. If you take any material there itself, any material if you are taking, its net charge will be equal to 0. Net charge is equal to 0. If you are taking here, metals are the charge carriers. If I take a metal, how many charge per electrons, the number of electrons existing in metal will be more. Within this particular metals, if you are going it up, if you go for metals like aluminium, copper, as well as silver, if you go for aluminium, its number of electrons will be existing in what? 3 plus 3 electrons will be existing. Copper it will be having 2, as well as silver will be having 1 electron. Which what? Majority more number of electrons existing in copper will be plus 3. Aluminium will be plus 3. Copper will be plus 2, silver will be 1. If you take it up half filled, it must be having 4 electrons. If it is completely filled, it must have 8 electrons. 3 electrons extra existing in aluminium, 2 electrons existing in copper. silver existing 1 electron. If I take this element, then itself aluminium. If this is an aluminium element having 3 positive charges, 3 electrons and having 3 electrons in outermost shell. Therefore, by default, its net charge will be equal to 0. Net charge will be equal to 0. For this particular element, aluminium metal, if I apply, means what, 3 electrons in outermost shell orbit around the nucleus with certain energy. That is what, kinetic energy of mv square. For this particular one, whose net charge is equal to 0, for this particular aluminium, if I am applying certain quantity of energy, if it is gaining this particular energy, then what happens? The electrons which are orientating in the outermost shell orient with what, high speed. Due to that particular speed, the electrons may skip off from that particular orbit. Electrons which are existing in outermost orbit, how many electrons? 3 electrons. Those 3 electrons can be skip off from the outermost balancing orbit and forms an electron in nature. That electron is what? Free electron nature. As it is skipping off outside there itself, what happened there? It will be having now what? Net charge is equal to 0 before applying energy. After applying energy, then what happened? Net charge will be divided into 2 components. One is electrons have been skipped off, therefore it will have a positive charge and a negative charge. In this particular way, every electron, by applying certain quantity of energy, electrons gain that energy, and with a high kinetic energy, electron orbit around the nucleus. As it is revolving around the nucleus, one more force also will play a role. That force is centrifugal force also will be increases gradually. Due to increasing of centrifugal force, electron orbit with high speed and want to move away from the center. So that what happened? Free electrons will skip off from that particular orbit. So that after applying energy, it's split up in the form of one is positive ion, other one is negative ion. And one more question will come in our mind. What is that one? From where this particular atom is gaining this energy? This energy is gained by an atom from nature itself only. Nature, if you take it of temperature, nature is also in temperature there itself. If you go for temperature minus 273 degrees centigrade is equal to 0 Kelvin. If I am taking room temperature is equal to 27 degrees centigrade, therefore 300 Kelvin temperature, an atom can gain energy within the nature. Every body which is existing in the nature will have will be affected by minimum temperature. That temperature is 300 Kelvin energy. As the mass of electron is negligible, it is 2000 times lesser than the mass of proton. Therefore, it requires a little bit minimum energy to skip off from that particular orbit. But here we are applying how much temperature? 300 degree Kelvin temperature we are applying it up. So that the electron gains, the electrons are existing in valence shell. Aluminum is having 3 electrons extra. Copper is having 2 electrons extra. Silver is having 1 electron extra. These electrons which are existing in valency orbit, outermost orbit, gain energy. As they are gaining energy, they cannot exist within that orbit. So what happened? Electron revolves around it. Kinetic energy is increasing. Not only kinetic energy, centrifugal force is also increasing. Allow that but electrons to move away from the orbit. As they are moving away from the orbit, they are attaining, those electrons are attaining one nature. That nature is nothing but what? Free electron nature. What is that nature? Free electron nature. Due to having free electron nature only, we can say that conductors are having 10 to the power of 29 electrons per meter cube. If you check this particular one, as electron is orbiting outside, what happened? Positive charge is existing, negative charge is existing. For one electron, one positive charge, one negative charge. Similarly, if the 3 electrons are moving, 3 electrons, 3 positive charges will be get existing here. If I take a metallic substance, this is a metallic substance in which equal number of positive charges and equal number of negative charges will be get existing. Among these all things, in conductors you have seen clearly that charge carriers are nothing but what? Electrons. Charge carriers are nothing but what? Electrons. Therefore, equally the charge, it has been split up in such a way that we are having free electrons of nearly 10 to the power of 29 electrons per meter cube, as well as we are having equal number of positive charges. These positive charges are fixed. Who said that word? Lorentz as well as Drude, they said that they are fixed to certain region. That region is called as nothing but what region? Lattice region is written. And electrons are nothing but what? They are charge carriers. They will be carrying energy from one point to another point. Now we are going to discuss Drude as well as Lorentz. In 19th century, two scientists, they want to explain the free motion electrons which are existing in this particular material called as conductor, how they behave in lattice region. How they behave in lattice region, they want to explain that particular phenomena. That particular phenomena can be explained in two different ways. First one is what? When the conductor is connected, in absence of electric field, how that particular electrons will behave. Charge carriers will behave in absence of electric field. We have to study about that particular point. Not only that one, in presence of electric field, how the charge carrier electrons behave. That particular phenomena now we are going to study. By this particular phenomena, absence of electric field, how the electrons are behaving, which will results to one velocity. That velocity is nothing but what? Thermal velocity. And in presence of electric field, what is the energy, what is the electrons are experiencing, that can be explained by means of a concept called as a drift velocity. Okay, children? Now we have to go how an electron behaves. Electrons behaves in lattice region where it is fixed. We have seen clearly that electron behaves in two different ways. In absence of electric field, it behaves in one way. In presence of electric field, it behaves in another way. Now we are going to discuss about in absence of electric field, how electrons will behave. That study is called as thermal velocity. If you go for a conductor wire, I have taken a conductor wire there itself, in which I have taken electrons. Electrons are charge carriers. As electrons are charge carriers, lattice regions are fixed. How many number of electrons are there? That many number of positive charges will be exist by a conductor, and that positive charge is fixed to certain region. That region is called as lattice region. We are seeing it up. If you observe the electrons within this conductor, then we are seeing that electrons are moving randomly. Electrons are moving what? Randomly in absence of electric field. When electric field is not applied, electrons will move randomly in all different directions. And these electrons absorb certain quantity of energy, that is nothing but what? Thermal energy. From where this energy is absorbed in previous class we have discussed that itself. From the nature itself, every material will gain temperature of 300 degree Kelvin, means what? From nature itself only these electrons, this conducting wire is absorbing energy. Absorbing energy from nature is called as what? Thermal energy. At room temperature of 300 Kelvin degrees, 300 Kelvin it is observing that at that temperature it is observing thermal energy. As it is observing this thermal energy, these electrons, they are attaining a motion. That motion is nothing but what? Randomly motion it is attaining is what? Electrons are moving in all different directions there itself. Some electrons are moving from left to right, some electrons moving from right to left, some electrons are moving in upward direction, some electrons are moving in downward direction, some electrons are moving in this direction, some electrons are moving in a slightly opposite direction. In that way they are moving it up. Such that these electrons move with high speed of nearly 10 to the power of 4 kilometers per second. 10 to the power of 4 kilometers per second, each electron will be orbiting within that particular conductor. Randomly they will be moving it up, and that velocity is called as nothing but what? Thermal velocity. We can give it up. As these electrons are moving randomly in different direction, what happened? See here, this electron moving randomly in this direction. Here one positive lattice is there. It collides with that particular positive lattice. And again this electron is moving in a changing its direction. Again it is colliding with the positive lattice there, changing its direction. So in different directions randomly, electron, if I take an individual electron, it is moving different direction. Again from here electron is moving in this direction. Here one lattice region is there, collided. Then again electron is moving in this direction, colliding with a lattice region, and so that what happens, the motion of electron within conductor will be in what way means in zigzag motion. It will be existing such that the net charge flow of that particular electron, which are moving in this direction, some electrons 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 are moving in this direction, all different direction, and is it flowing, net flow of charge will be equal to 0. That is the absolute up. The electron which is moving in this direction, B has got U1. The electron which is moving in this direction, B has U2. Some of these two things, one is in positive direction, other one is in negative direction. U1 minus U2. If it is positive velocity, it is negative velocity. Equal velocity but in opposite direction, it will be equal to 0. Here also equal velocity but in opposite direction, it also will be equal to 0. Equal velocity in opposite direction, its velocity also will be equal to 0. It is moving with velocity of 10 to the power of 4 kilometers per second. Each electron will move with that particular speed in opposite direction. Due to that reason, what happened? Thermal velocity will be again to 0, as it is moving in all direction. Average velocity of thermal velocity take it up U1 plus U2 plus U3 plus U4 plus so on to Un by number of charges. Number of that particular electrons if we take it up, we will get thermal velocity is equal to nothing but what? 0. And one more point also we can understand here. We have studied clearly that what is called as electric current means what? Rate of flow of charges. Rate of flow of charges. If a charged particle is attaining motion, if a charge is accelerating from one point to another point, we are saying that it is nothing but what? Electric current. But here also charged particles are attaining motion. They are also accelerating from one point to another point. From one point to another point, colliding it up with lattice. Again coming back to and coming in another direction, colliding with lattice. Coming in another direction, colliding with lattice. Coming in another direction, colliding with lattice. Therefore, electron is also accelerating, but randomly it is accelerating. It is accelerating with the speed of 10 to the power of 4 kilometers per second in all different directions, such that the net charge will be equal to 0. Due to that reason, thermal velocity will be equal to 0, which does not produce current flow in a circuit. Thermal velocity doesn't allow charge, as charge is accelerating within thermal by means of thermal velocity, but acceleration of charge is not resulting in the form of flow of current here. Therefore, thermal velocity does not allow current to flow through a circuit, as it is accelerating, but randomly it is accelerating in all different directions. Due to that reason, net flow of charge will be equal to 0. Why? Number of electrons are moving in this direction will be equal to number of electrons moving in opposite direction. Number of electrons moving in upward direction is equal to number of electrons moving in downward direction. Number of electrons moving in this direction, in all different directions, we will have opposite direction. Due to that reason, its velocity will be equal to 0, due to which current does not flow. Then how current flow will be taken place? By means of another velocity I said. What is that velocity? Drift velocity. When we apply electric field, in presence of electric field, if we allow charge carriers to attain one motion, that motion is what? Drift velocity. Then the flow of charges will be taken place. How that particular flow of charges will be taken place in next video we'll discuss. Till that time, children, try to analyze the concept what we have studied. Thank you, children.